By the end of this video, you should be able to implement this effect, or you can pause and copy it down now if you don't want to watch the whole thing. Hello everyone, and welcome to a new mini-series, Fine, I'll Go Do It Myself, where I replicate effects or suggestions within the Godot game engine. Today, I'll be making a rave effect, or a rainbow effect. This assumes you have a basic knowledge of scene management and various functions of Godot. Let's get straight into it, shall we? To begin, we'll create a simple sprite, and as is tradition, use icon.svg. Press F5 and select the current scene, and we'll save it into a folder called Scenes, just to keep things organized. And there we go, we've got a game. Job's done, we can go home. But wait, there's more. We'll create a simple script inside, again, a folder called Scripts, and we'll call it Rave. Now, this script will be what handles the rave or rainbow effect. We actually want it to inherit from Node 2D, so we can use it on any node that extends from Node 2D, which is quite a lot. Now that we are working directly on Node 2D, anything that extends from it will be able to use this functionality. And I'll show that later. We want to start by declaring a float called hue and setting it to 0.0. Cool, makes it a float. Then we want to start our physics process loop. Now this is a process loop that happens every physics frame, which means that delta is quite important here. We want our hue to be increased by our delta, so that every second we are increasing hue by 1. And then what we want to do is utilize a nice little thing that comes handy with Node 2D, the canvas items, modulate or self-modulate options. I'll be opting for self-modulate, but you can use modulate if you just want to tint a whole group. So, we can access that by going self-modulate, and it auto-completes there, or if you're worried or want to ever know what any of these are, you can right-click and just copy the property path, and then paste it in, and in this case it's self-modulate. We want to set that to a color, and we want to use hue, saturation, and value. Now, this is a nice little thing. You control-click the function, and we pass it a float of hue, a float of saturation, and a float of value. And there's a default float of 1 for the alpha. Now, these are generally between 0 and 1. Anything over that, I believe, starts working on the emission territory. But I don't have anything set up for that, so this will be fine for now. Simply put, if you want a really nasty, dirty way to do it, without any fixes or any care for future-proofing, that will do, right there. If I press F5 right now, you'll see I'm rainbowing. And all you're seeing in here, if I pop over to the remote so I can see what's actually happening, is it's adjusting the hue, which spins it around this wheel. Now, for a better understanding of how that actually is all working, if you ever used an application like Photoshop, for example, you've probably met this hue and saturation wheel. And all we're doing is incrementing this hue value here from 0 to 255, or in the case here, from 0 to 1 as it's a float. And so it's processing constantly, going from there, back to there, back to there. And that's how we get the nice rainbow effect, because that is just a rainbow. Awesome. But, like I said, this is going to cause issues if you're not careful. Say you leave your game running for 20 hours, you'll start hitting floating point issues and a potential memory leak, I guess you could call it. Why? Well, if I just print this out here, we'll see in the console what's actually happening each frame. Hue is just constantly being incremented, ad infinitum. It will never stop, ever. And if you were to do this in a game that was a lot larger than this simple scene here, you might end up causing problems. So for that purpose, what we'll want to do is actually limit this. And we can do that by going, as a basic, if hue is greater than 1, then we want hue to be reduced by 1. Now we don't set this to 0.0 because we'll actually lose some of these additional floating points here, as every frame isn't exact, and it'll always change based on the screen refresh rate and the system that the game is running on. So for example here, the very first step after this, we would have lost that. This would have been greater than 1, and we would have lost that going back to 0. Not that big of a deal, but I'd like to make things robust and definitely 100% work the way that I want them to work. So, for example, if we had that, and we were to set it to 0, we lose that 0.015. But when we reduce it by 1, basic math, we then end up with 0.015. And that will be the next frame. It increments that by delta, and it will just continually move forward, never losing its place. Now, I would also at the same time suggest that we add some form of user, or since you're the developer, ability to control this. So we'll make a function, well not function, sorry, a variable called cycles per second. That will also be a float, and we'll set it to 1.0 as default. So it should do 1 cycle every second. And as you probably know, all we need to do to make that happen is multiply the delta that we're adding by the cycles per second, as this is the fraction of a second that is occurring during this physics frame. If we multiply it by 2, then it's going to be twice as fast, which means we'll have 2 cycles per second. If we multiply it by 0.5, it'll be half as fast, so we'll get every 2 seconds 1 cycle. Sorry, my brain's turning off and on. Cool, and then we can make that a one-liner like that, and it's neat. But we can make it even smaller. Just to confirm that this is now fixing the issue, obviously, anyone that can see it would know, it is definitely not preaching 1 now. And that'll constantly work. You can leave that running for years. I mean, there'll probably be issues with the computer at that point, but this could be running for years without causing any issues. You're not going to blow out your memory by increasing a number beyond the float limit, which is technically infinite, but anyway. Nothing ever works the way you think when you get a crazy number crunching like that. I want to go a little bit further, and this will be what you saw on the intro. If you didn't understand it, we're going to use what is known as a modulo operation. So if I were to do this in C# or Unity, for example, I would do something like, I'd actually do it like that, but like that. And what that is doing is setting u to its own value plus the fragment that we're increasing, modulo 1.0. Modulo gives you the remainder of the divisor using the same sign as the divisor. The remainder of the divisor by the divised. It's always explained a little differently. But this won't actually work in Godot, because this is how you do integer modulo. It actually has a separate function. We need to do what is called fmod. And we can look that up here. All the docs for Godot are within the application. It makes it so clean and nice by passing x and y into fmod. And this will return the floating point remainder of x divided by y, keeping the sign of x. So, in the example they give, fmod 7 by 5.5 gives you the remainder of 1.5. Because as we know, 7 divided by 5.5 is 1, remainder 1.5. Or if you want to see it that way, like that. We're taking 5.5 off it, that gives us 1 and 1.5. This just returns the remainder. It doesn't return the divided amount. Awesome, that's an easy way to explain that. So what we need to do here now to make this work is not from, keep typing the wrong thing, we want to fmod that value by 1.0, and we'll add that print in here again, just so that we can see that yes, it is working 100%. As we're now causing it every time it steps over 1 to loop back to 0 plus whatever the remainder was. And there we go, a single line. Now, the really cool thing, because we're extending this from Node2D like I mentioned before, it means that we can add any other Node2D. So, hop into Node2D, all of these, as long as they're a canvas item, we can play with. Let's make a mesh instance, for example. And we'll just make this a quad mesh because we're working in 2D. And we'll throw that there, and we'll put it up above here. Awesome. Now, without having to do anything, I can just grab that script, drag it on there, and press F5. And look, we've got some crazy rave happening. Awesome. And we can even adjust the cycles per second. We'll make this one go slow, and we'll make this one go fast. If I could click inside the cell. Whoa, so much rainbow. Disco, disco party. Yeah. But that's not all. Since this is such a simple thing, we could do this as well to 3D. So let's do that. We'll make a new 3D scene. We'll call it Development 3D. Actually, I did, yes, cool. But because it's 3D, we'll need to actually add a few things as well. So we'll add a camera. We'll add a directional light, if I could type. And we'll just set this up really quickly like this. drag that back up here and rotate that down there. And then we'll also add a CSG polygon, or just box. Okay, that'll do. And that gives us a simple 3D model of... Love it. Let's just pull this back a little bit. It's going to look pretty much the same, but a bit smaller. Cool, okay. So that gives us a nice 3D object to work with. Now, this is a bit different because it doesn't have the visibility options that a 2D object has. It's only got whether it is on or off. Instead, we need to, as working with 3D, use materials. So, if we were to make this specifically for this CSG box, we can attach a script. We'll make it Rave 3D. And we'll extend CSG box. And that gives us access to, we can just go var cube float, same thing, float equals 0.0. In fact, we can just copy this out of here rather than retyping it. What is it? Dry. Don't repeat yourself. That's the motto, isn't it? Okay, and then we want to do the same thing here, except what we'll want is, if we hop into here, albedo color. So this is what changes the color of the actual box itself. We can see that by changing this over here, and it changes on the screen here. Cool. So, again, if you're not too sure what you want, got to jump in here, you can just right-click and copy, and it's called albedo color. But that won't work because it needs to be under material. So, since we're extending CSG box, we can access any of its values like that, or properties like that. We can save this as development 3D, sure. And there, if we were to just use F6, we're done. We've now got a CSG box that is also running the Disco Inferno soundtrack in its head. But, as with the other 2D example, I'd like to do it from Node 3D, so that if we have another Node 3D, say animated skeleton mesh or a model that someone's imported, it's not going to be able to do the same thing, unless we do something like this. We make an export variable, which is just material. That's all it's looking for, and then we adjust that. Now, as long as we pass the correct material to this through its export variable here, we'll be able to adjust that. And in the case of this CSG box, which is, extended from Node 3D, which is great, I can just drag and drop that in there, and now it'll still work. Oh, I pressed the wrong button. It's F6 for the current scene. Still works. A nice disco rave cube. And we should be able to see through the remote, potentially. No, we can't. It doesn't actually update because it's a separate object here, but we can see this updating here. So that's cool. A disco cube. And that will work with other objects as long as we pass in that material. And now you might save that material in here and then make it local to scene, but it just works. There we go. And that's how you make a nice rainbow rave effect. If you'd like to just grab a copy of the scripts and everything that you're seeing here in this scene, I'll have a link to my GitHub with this repository up there in the description below, and you can just pilfer it and take it. Use it, do whatever you want with it. I don't really mind. Now, moving forward with this little mini-series, if you have any suggestions of effects from video games that you would like to see attempted to be replicated in Godot, I'm quite happy to do the exploration and create a video on how I think they've done it, or potentially how it can be done. I'm not an expert, but I am pretty knowledgeable. So put your suggestions in the comments below, and we'll see what we find. Whether it's some sort of attack effect, or how Path of Exile makes their skill system, for example. I've already got one half done. I can brush that off and make a video of that. It's quite fun. But for now, until next time, farewell.